Thank you, Connor. Thank you, Connor, for doing that. Thank you, Connor. Now you're in. Yeah. All right. So now Connor just made the Hall of Fame of coughing. Nice job, buddy.
Yes.
Okay, so you can watch this video. This one's dedicated to you. All right. Here's what I want you to do first. We have 3 boxes. The first thing I want you to do is I want you to do a little review, a little practice for your quiz on Thursday. Right now, you and the person sitting next to you solve this little 2-equation, 2-variable linear system using addition and or substitution. Ready, set, go. Toby, walk me through it, buddy. So you chose to get rid of the y's. Okay, awesome.
And you multiply the bottom equation by 4.
By 4. Okay, what did that give you when you did that?
That gave me 12x. Or do you want the end solution or just?
No, yeah, step by step. Just tell me step by step.
Right, so then that was 9x minus 8y equals -24.
Mm-hmm.
And then you add that to 12x plus 8y equals 192.
192. Okay, good. 168. Okay, so we eliminated the y's. Yeah, so notice that the y's have now been eliminated. Good. So if I divide both sides by 21, I get a value of x equal to 8. Okay, great. Are we done? No, we're not done. What do we do now? Yeah, exactly. So you can pick any one that you want. Which one did you pick? The bottom one. So you went right here. So you did 3 times 8 plus 2y is then equal to 48. So go ahead. When you finish this off, what'd you get? Yeah. Y equals 12. Okay, can we agree that our solution is the point 8, 12? Can we agree with that? Is that good? Everybody agrees with that. Okay, so this is review. This is from the last time, all right? And what I want you to do now is I want you to try something on Desmos that I've created that's going to help us get to the next level that I want us to go to, okay? So please right now go to Canvas. Okay, go to the Canvas page, our pre-calculus Canvas page. It only takes maybe 1 computer per team, is fine, okay? And if you go to the scroll to the bottom of modular 7, and at the very bottom you will see it says Desmos 7.2 number 1. There's a number 1 and a number 2. Please click on the number 1, and you should see this when you open it up. Okay, you should see this, something that looks very similar to this. Okay, and then see, you'll know when you see these little words up here, this 2 linear equations, that's where you should be. So I'll take a moment, let everybody get to there. All right, first thing I want you to do is over on the right-hand side, there's a graph settings. Okay, if you click on that, put your computer in projector mode. I think it makes the graphs a lot easier to see and read, okay? It makes the graphs a lot easier to see and read, okay? So, once you're in projector mode, you can click that little wrench and then it goes away on the right-hand side. Okay, here is what I want you to do, all right? Here's what I gave you. I've given you a point. The point I've given you is 8, 12. That point is right over here, and notice if you click the point, it kind of goes away and it comes back on, then goes away and goes back on, okay, if you want to do it, okay? Here's what I want you to do. There are 2 dashed black lines here, and then there is a blue line, and then there is a purple line. And trust me, this is all leading somewhere else, but this is the first step, okay? Here's what I would like you to do. Notice that over here on the left-hand side, without scrolling all the way down, do not go past the F. Do not go past the F. See where it says the F? Don't go past there. Or, sorry, the G. Don't go past the G. Thank you. There it is, the G. So on the left-hand side, I have a purple, and I have a blue. This purple over here is AX plus BY equals C. What is AX plus BY equals C? Standard form of a what? Of a line. Very good. Okay. So the A value is the coefficient in front of the X. The B value is the coefficient in front of the Y, and the C value is a constant. Notice that when I take this little slider here and I move the A value, notice my purple line moves, okay, in a certain direction. Notice if I do it for the B, it also moves in a certain direction. And then notice if I do it for the C, it also moves in a certain direction, okay? And you have the same thing, check it out, for the blue. I just used D, F, and G. So when I move the D, the blue line moves a little bit. F, it moves a little bit more, and then it moves a little bit more. Here is your task, okay? Your task is to take the purple line and the blue line and to try and line them up exactly with the dashed lines, but I'm not going to tell you which line goes with which dashed. That's what you and your partner have to try and figure out. So as right now, my purple line is getting more and more like that dashed line there. And maybe if I could get this to, move up and down a little bit, I can try and make it fit. So right now, just play. See how close you can get to get those lines to match up, but I'm not going to tell you which line is which. And please do not move any lower than the G, which is box 10 on the left-hand side over here, okay? Right now, 2 minutes, ready, set, play. Okay, hopefully you guys had a little bit of fun. There's a purpose to this. There is something that I'm trying to tie together. But before we do that, let's talk about some of your guesses that you had. So who thinks they have a really good approximation of the purple line? Yes. Go ahead. What'd you get for A?
5.2.
Okay, little trick here. Did you know you can actually type this in if you want? Yeah, 5.2. Okay, 5.2, good.
Oh,
What's your value of B?
-4.
still perfect.
Negative 4.6. So negative 4.6. I'll type it in there, okay. And then what's your value for C? Negative 13.6. 13.6. And that's the purple one. What do you guys think? Is she pretty close to that? So she thinks it's 5.2x plus or minus 4.6y equals negative 13.6. Okay, good. What's your value for D, E, and G? What'd you get for that one?
-0.9.
She says negative 0.9. Okay, let's go that one. Negative 0.9. Yeah. Negative 0.6. Negative 0.6. Okay.
And -14.
Negative 14.4. Negative 14.4. Okay. What do you guys think? Is that pretty good?
We have different numbers, but ours is all
Yeah, okay. That's pretty. Is that pretty good? What do you guys think? Is that pretty straight on?
Yep. I mean, I would say it's pretty perfect.
It's pretty perfect. Okay. All right. Pretty good. Okay.
I don't know.
All right. Hey, does anybody have anything else? This is really good because I got something totally different. Does anybody have anything else for A, B, and C?
Yeah.
Claire, what'd you have for A, B, and C?
Ours is not probably as exact, but
What'd you-
we have like -10.
Negative 10 for A. Okay. Negative 10. Got it.
B is 8.8.
B is 8.8. 8.8. Sweet. Okay.
C is 26.
26. Whoa. Hey, that's pretty good too, right? Pretty darn
We
close.
got 3.
But if we zoom in, if a little bit here, yeah, we zoom in. Okay, pretty close though. That's pretty darn good. It's pretty darn good. Okay, anybody else have anything else that they want to go? Yes. What'd you get?
3.
Yeah, for part A.
Yeah. 3, 2, and then 48.
3. So you just got
Just use the equation.
No.
3, and then 2. And then 2, and then what? 48? And then 48. Okay, good. And then what's the other one?
And then 9, -8, and -24.
9,
Oh, it's on the money.
negative 8. What'd you say? Negative 8?
Yeah.
And what's the other one?
-24.
Negative 24. Okay, all right. Okay, yes, indeed. That of course is the two answers that were down here.
That's not how we didn't use that.
You didn't use that? Okay.
No, we just
Okay.
jiggled it around.
All right, you didn't have to use it. That's okay. You didn't have to use it. But here's the point I'm trying to make, okay? This is if you'll notice, if you get back to our notes, you notice this is the exact same system that we solved. Did anybody put that together? Yeah, this is the exact same. I gave you 9x minus 8y is negative 24, and then I gave you 3x plus 2y equals 48. And look, we solved it, and we got 812. That's exactly what we did over here, right? But the cool thing about linear systems is that, remember, we could have different lines represent, there are different ways to represent the same line, right? Like if I just doubled all these values, I would have another representation of this, right? So the point that I'm trying to make here is that we can, by solving systems, we can get these coefficients out of it, okay? Now, we're going to take this same procedure, this same kind of exploratory idea, and we're going to investigate a quadratic. So I need you to open up part 2 for me, please. Okay, so go back to,
Should we keep part 1 open?
you don't need to have part 1 open. This was just kind of a warm-up, kind of like get your brain thinking in the right direction. Okay, I want you guys can go now to part 2, okay? And here is part 2. I'll wait for everybody to get there.
Is it just 3 dots and
Yeah, you should see this. I already have mine open for you. You should see something that looks like this. Yep, you got it. All right, here is the really neat thing about this. So I gave you 3 points, and you'll notice, you guys, on this one, the answer is nowhere on the page, so you can't cheat about this one, okay? I'm not saying you guys did cheat. I'm just saying there's nowhere to look for the answer besides this one, okay? So check it out. I've given you 3 points. I've given you -2, 7, which is this one here. So go ahead and click the points and make sure that they come up on the screen so you can see them all. 2, 3, and then I gave you a 1 and a -2, okay? And then here is your task. The neat thing about quadratics is that if you're given any 3 points that are non-collinear, what's non-collinear mean? Not on the same line. If you are given any 3 points that are non-collinear like I've given you here, it turns out there is one and only one quadratic that satisfies those 3 points. Okay? Here is your task.
Was there in the same
No, just because only one quadratic will satisfy it. The cool thing is this. Okay, I've given you an A, a B, a C, and this thing is equal to Y. So this is a general quadratic, okay? Your goal right now is to do the same thing we did with the lines, but do it with the quadratic. I want you to move the value of A around until you can get it to go in the value of B, until you in the value of C, until you can match it up as best you think you can to get it to go through those 3 points right there. Okay, does everyone understand their task? It's not impossible. The last class did it, and I guarantee you guys can do it too. Okay, ready, set, go, play. Okay, so back to, these are all about your guesses. I gave you 3 points. What were the 3 points I gave you again, guys? -2, 7, yeah. And then what? And then 1, -2. No, we're going to solve it together. 1, -2, and then the other one was what? 2, and then 3. Okay, I gave you 3 points. And then I said through any 3 points, right there, as long as they're non-collinear, there is exactly one quadratic. So let's talk about what your guesses were. So anybody having a good guess? Fellas in the back, what did you come up with?
A equals 2.
So they got an A value that equals 2.
B equals -1.
B equals -1.
C equals, it says -3.1, but I'm going to say it's -3.
-3, okay. Anybody else having any other guesses that they want to try?
we would guess it's almost the exact same thing.
Okay.
except we have like 2.1 and -3.2.
A was like 2.1, and then B was -1, and C was -2.3.2. Is that what you said? Okay, so these are our guesses here, okay? And let's go back and try it. Let's just go ahead and try it, okay? So if we move the A to -2, right? Is that what we said?
What?
Was A? Oh, +2, thank you. A, +2. Okay, there's 2. B was what? -1. Right there. And C was? -3. What do you guys think? Does that quadratic go through exactly those 3 points?
We got the same.
It's pretty darn close, right? So we think through investigation and through playing with this Desmos activity thing here, we think that given these 3 points right here, the values of A, B, and C are 2, -1, and -3. That's what we think, okay? Now I'm going to show you in box 3 how to actually solve this and prove to you guys that that choice is actually correct. Okay, you guys are actually correct. Okay, sorry that writing is a little sloppy, but that's okay. Okay, so it says here, so given 3 non-collinear points, find the quadratic that satisfies ax squared plus bx plus c equals y given the 3 points, all right? We already think that the answer is A is 2, B is -1, and C is -3 because that quadratic fits pretty nicely in with the 3 points that I've given you, as with some investigation over here, right? So you guys have done a pretty good job so far of coming up with that yourselves, all right? Oh, where did my video go? Wait for it. You were the star of it. I think it's recording right now, so I think we're good. Okay. Anyways, at least I hope it is. Anyways, okay. So here we go. Here's how you solve this on your own. Okay. Notice that this is an x and this is a y. You guys agree with that?
Yes.
And you have that for each of these: x and y, x and y. So for each point, we could write this down. We could write down y is equal to ax squared plus bx plus c. Well, the y value is worth 7, So 7 is worth, let's see here, negative 2 squared is 4, so I'm getting 4a minus 2b plus c. All I did was I plugged in the value of negative 2 for x into the generic y equals ax squared plus bx plus c. The c is 0 in this case. I have no value of c. It's just 0. How do I get 4? Because negative 2 squared is 4. Okay. I can do the same thing for the other 2 points, can't I? Watch this. Y equals ax squared. I'll start with this. Ax squared plus bx plus c. That's the generic quadratic, right? I know it has to satisfy when x is 1, y is negative 2. So negative 2 has to be, well, 1 squared is 1, so that's just a, plus b, and then plus a c, right? Because x is a value of 1. And then I can also do the same thing for the third one as well. So when y is equal to 3, I'm getting, let's see here, 2 squared is 4, so that's going to be 4a, plus 3b, and then plus c. Whoa, not 3, excuse me. 2b, thank you. 2b. Ax squared plus bx plus c. Okay? Alright, so look what we have. We have a system now, you guys. If I write all these together, look, 7 equals 4a minus 2b plus c, and negative 2 equals a plus b plus c, and then last one was 3 equals 4a plus 2b plus c. Hey, that's a system right there, and we can solve that system. And remember that the strategy is to pick a variable, eliminate it from 2 equations, pick that same variable, eliminate it from 2 different equations, and then use back substitution. So which variable would you like to get rid of?
I think you're gonna have to decide this first.
Look, if you do C,
Alright, let's just do the
I
first
think you
one.
should
Let's
eliminate
get around
B because
B.
you just eliminate it.
Okay,
yeah, but if
here's what I'm going to do.
you A, then automatically eliminates B.
Yep, I'm going to actually eliminate c from the top 2. I'm going to eliminate c from the top 2. In order to do that, I'm just going to actually subtract the 2. Watch this. 7 equals 4a minus 2b plus c, right? And then negative 2. Actually, I'm going to eliminate c from these 2. Oh, there we go. 3 equals 4a plus 2b plus c. And I'm just going to actually subtract them. Let's see here. 7 minus 3, how much is that? 4, very good. Equals 4a minus 4a. That goes away. How nicely. 2b minus a 2b is a negative 4b. And then c minus c is nothing again. Hey, if I divide both sides by negative 4, I confirm that b is worth negative 1. Hey, isn't that exactly what we thought it was over here? B was worth a negative 1? Mind blown. Mind blown. Okay, so now that b is worth negative 1, remember the strategy again is to pick 2 different equations and again eliminate the b. So I'll choose the purple.
Or you could pick 2 different equations and eliminate C.
I'm sorry, did I say b? I meant c. So which ones do you guys want to eliminate?
First and second.
Okay, first and second. Let's eliminate c again. So in order to eliminate c, you have to just subtract them again, right? So 7 equals 4a minus 2b plus c. And then negative 2 equals a plus b plus c. And again, I'm just going to subtract. So 7 take away a negative 2, how much is that? 9, right? Positive 9, okay. 4 minus a is? 3a. Okay, negative 2b.
Positive 9?
No, it's not. It's
No, 7 minus negative 2, that's 9. Yeah, we're good. Okay. 4 minus 1 is 3, that's fine. 2b minus a b is a negative 3b, right? And then c minus c, that goes away. But how much is b worth?
1.
B is worth negative 1. So now I have 9 is now worth 3a minus 3 times negative 1.
Plus 3.
So that means that 9 is equal to 3a plus a 3. So that means that 6 is equal to 3a. That means that a is equal to 2, which is exactly what we thought it was over here as well. Because look, a is equal to 2. Where is it?
Right below the little computer board.
Yeah.
You see that thing? It's
Oh, yeah, I see it. Yeah. Maybe it is recording. Cool. Awesome. And then over here, last thing we have to do is do what? we need the value of c, right? So we can plug it in. This one looks the easiest to me, right? So negative 2 equals the value of a, which was 2, plus the value of b, which was negative 1, plus the value of c. So negative 2 is equal to, 2 minus 1 is just 1, right? 1 plus c. So therefore c is equal to? Negative 3. Negative 3, right? Go back over here. And yes, c is actually equal to negative 3. How cool is that? So the algebra supports exactly what we've done. And you guys, you know what? This is problem number 20 out of your book. And you have homework problems number 19 and 21. So I did the one right in the middle for you to show you how it's done, okay? Okay, ladies and gentlemen, we are done. Oh, there we go. Sweet.